Hi, my name is Roger Machut. I'm the Senior Civil Engineering Consultant with Solution Engineering Group. I've been practicing civil engineering for 36 years. I hold a Bachelor of Science in Civil Engineering degree from Tulane University, as well as a Master of Science degree in Strategic Studies from the U.S. Army War College. I'm a registered professional engineer in the state of Illinois, and I have a LEED accredited professional credential as well. In my experience, I've been involved in a wide variety of civil engineering projects. Now, civil engineering as a whole can be considered things that don't move. Items that are built to help society, such as roadways, sidewalks, bridges, buildings, dams, water mains, sewers, airports. The materials that are involved in civil engineering, steel, concrete, even stone, all things that help our society maintain their style of life. Concrete is one of the oldest building materials that we have. Concrete really is nothing more than stone and something to hold it together. You can see around us that we have concrete columns that are holding up the ceiling above us and the building above us, formed within a shape to be able to support the great weights from above. Concrete can also be used for slabs on a floor or in a roadway. It's also used quite frequently for beams that are supported between columns, such as you see around us. But one of the downsides of concrete is that it's very weak in tension. And what I mean by that is that it doesn't take as much force to pull it apart as it will take in compression when you're pushing on it. In fact, concrete is 10 times stronger in compression than it is in tension. Why this is important is because it affects the way beams and columns and slabs can actually work. As a demonstration, if you were to imagine that this piece of foam is a concrete beam supported on either end, and a weight applied in the middle, you can see that our concrete beam actually bends. Up in the top, the area starts pushing together in compression. On the lower edge, it's being pulled apart in tension. If I was to continue pushing on this beam, you will start to notice cracks in the bottom because the tension, the forces pulling the concrete apart, will exceed the ability of the concrete to hold together. Now, in civil engineering, we mitigate those tension forces, the weak tension forces, by adding steel. In a beam, we would add reinforcing steel so that the tension forces are actually picked up by the steel and not the concrete. In slabs, we add steel mesh to be able to hold the concrete together as it tries to pull apart when it expands due to temperature or local loads. And a lot of times you see cracks in concrete on the sidewalks and in the roadways. This also is the concrete pulling apart because of it expanding. Some people actually know about roadways that have buckled up suddenly in a hot summer day. What this typically, though, is not the concrete failing, but the expansion joints in the roadway failing, not allowing the growth of that concrete because of the heat. One of the interesting things that I love about this job is that throughout much of my career, I've been designing things so that they don't fail, so that they don't break. Now I get the chance to backwards engineering. Something has failed, and I have to do the mental exercise of figuring out why it didn't work, what had failed. Was it the material? Was it the design? Was it the operation or the application? It's mentally exciting to be able to do this, to solve those puzzles, to solve the questions of why.